Security Issues in Routers by Mr. Saurabh from Computer Science Department of NITTR Chandigarh.
So good afternoon to all the remote centers, and I'd like to thank Dr. Garima Saini for giving me an opportunity to share some of my knowledge related to router security. In this particular session, we will be having a look at basically the open source router. You must be that how I can demonstrate the security issues in the router. You must have seen a router first of all, right? Let me show a presentation to you first of all. So I'm carrying my new laptop today, and I think I forgot all the presentations in my previous laptop. So not an issue. We'll be having a look at the open source router today. There are basically 2 or 3 open source routers available with us. First of all, let's understand what do we mean by a router. Any remote center would like to answer? Let's make this session as interactive as possible. I don't want to feel like a politician, that no one is responding from the remote center and I'm just speaking. Any remote center would like to answer what do we mean by a router basically? We are conducting a short-term course on wireless and mobile communication. So, whenever we're talking about communication.
Yes, from Kite, we have any feedback?
Any query?
Yes, sir.
So what do we mean by router? First of all, we are about to start the session on security issues in the router. My question is open for all the remote centers. That what do we mean by a router? First of all.
Hello.
Hello, yes, sir. You are audible, sir.
Yes, sir. You asking some questions, sir?
Sir is asking, do you know about router?
What do we mean by router basically? Why do we need it in our network? Since this is a particular STC is for the communication field, right? So I want to know that if we talk about any particular network, is it possible that we can communicate without a router?
So router is the main part of the network.
Main part of the network.
It receives the packet and transmits the packet to particular destination according to the IP address.
Okay, very nice. And if I want to ask a very layman definition, what do you mean by router in that case? Very layman definition that even I think everyone should understand.
Router provides the route for the packet for the destination.
Right, it provides a route, but again, if you want.
Sir, basically router just find the first route, congested free route. If there is congestion, then router choose the another path, then transmit the data.
Absolutely, that's done with the help of the routing protocols. But if we give a very basic definition of a router, that is basically used to connect 2 or more multiple networks together. That is a router.
Gateway and bridge, like.
Kind of a gateway device, but it is actually what it is actually doing is it is used to connect 2 or more multiple networks together. Let's take a analogy that we have a scenario that you have your corporate network, right? And there is another network, let's say our internet. If you want to go and connect to the internet, you have to have a router at your corporate environment, right? Or maybe at your engineering college or at your university. So we need to have a router. So please continue what you were saying.
We can connect different LAN using router, sir.
No. LANs are basically built, it is, let me explain, right?
Yes, in a single room LAN, sir.
Okay, I got your point. If we particularly talk about a switch, right? Switches are basically used to build a network. Let's say in your lab, where you must be sitting, right? You must be having certain PCs there. And if you want all PCs to communicate to each other, you need to have a small switch. where all PCs will be connected, and that will basically form a LAN. That is a local area network, right?
Yes,
You might be having your PCs, your shared printers, your IP phones, or whatever thing, possible thing which you want to have in your local area network. Now, if you want that particular LAN, that's your LAN, right? That's your corporate network. Now, if you want to go and connect to the internet, you have to have a small little device called as a router in between, which will actually connect your local area network to the internet. So basically, what router is doing, it is connecting one or more, two or more multiple networks together. That networks can be anything. You have your LAN, and then what you have is you have the internet. That's how things are working, right? Let me go ahead and open up Paint. Let's try to I'm really sorry, I forgot that I'm not carrying my presentation in this. Let's say this is your router. I'm very poor with drawing, so kindly bear with me in this part. Let's say you have your router, right? And you have a switch here. You have your switch. Now with this particular switch, you have multiple PCs connected, right? This will basically go ahead and inform your LAN. This is your PC. Another PC. Let's say PC number 2, and so on, right? Let's say you have multiple PCs here like this. Let's say this is a 24-port switch, and you have this PC here, which is PC number 24, right? So this basically has formed your local area network. This is your LAN. This is your LAN. Now this particular switch has one link going to this router, and this router is further connecting to another network, let's say our internet. This is the usual scenario, right? Let's say this is your internet. Okay. So now we need to understand, first of all, that we have a switch which has actually formed our local area network where all the PCs are connected. Now I'm saying that if we need to go and connect to the internet, first of all, we all are aware about that we need to have an IP address. Now we have two types of IP addresses available with us. One is your private IP address, private, and the another one is your public. You talk about any network, any corporate network, any university network, any small medium enterprise network, you will definitely find this device called as a router there, because it's the duty of the router to take your corporate network users out to the internet. Without having a router, you cannot even think of going to the internet, right? So you have your PCs here, you have this LAN segment. Now in this particular local area network, you are assigning your private IP addresses. Now private IP addresses are those which are available to us for free of cost. We need not to pay anything for our private IP address range. Basically, we have total of 5 classes. If we particularly talk about IPv4, we have class A, class B, class C, right? And within these classes, while these classes were defined in the RFCs, they have already defined a certain range. 10 range for class A, 172.16 range is basically for your class B, and 192.168 range is for your class C network, which is the private range, right? If you want to use any IP address from this particular range which I have mentioned, you need not to pay anything to the ISP. But if you talk about public IP addresses, public IP addresses are those which are actually known to the internet. And here we have our public. we have our public IP address allotted here. So without having a public IP address, we cannot go and communicate to the internet because private IP addresses are not known to the internet. We'll change a color. These are not known to the internet. If you want to go and connect to the internet, you have to have a public IP address. And public IP addresses are those which you actually procure. Maybe let's say you have procured your lease line, right? They will provide you with certain amount of public IP addresses available with them. So now let's understand the scenario. Let's say we are a poor company or a poor university, poor technical, institution. We only have got around, let's say, 2 public IP addresses. We have only 2 public IP addresses available with us. But we have around 24 users. We have around 24 users. One IP address will be consumed by this particular interface of a router. That's how your router will be able to go and connect to the internet, right? So this interface of a router will get one public IP address. So now we are only left with single public IP address available with us. So, and we have around 24 users from PC1 to PC number 24. There are 24 users who want to go simultaneously and access to the internet. So how will that be possible? And I have already mentioned that only public IP addresses are those which are known to the internet. These private IP addresses are not known to the internet. Let's say we IP address from, let's say, 172.16. Let's say 1.0. Oops. Consider this as a 0/24. Let's say I've subnetted this IP. So this PC number 1 is having the IP address of 172.16.1.1, and this is having the IP address of 172.16.1.24. Okay. So now all these users at a same time, they want to go and access to the internet. Let's say this PC number 1 approaches. He says that I am having a private IP address of 172.16.1.1, right? And I want to go and access to the internet. So how will that be possible? Since he is having a private IP address, so he won't be able to go and access to the internet, right? Because private IP addresses are not known to the internet. So what he'll do is he'll reach to the router. So here I introduce a new term called as a NAT, N-A-T, which is basically your network address translation. Network address translation. NAT is basically your one-to-one mapping. Let's say one public IP address and one pub IP address is equal to one private IP address. So basically this is one-to-one mapping. So now since PC number 1 came and he approached to the router, so router said, okay, I have one IP address vacant with me because one is already being consumed by interface of a router, right? So this PC number 1 approaches to the router. He says, now I want to go and access to the internet. Router says, okay, I have one public IP address available with me. What you can do is you can take this public IP address and go and access to the internet. So he says, okay, there's one. So now we have a one NAT translation inside this router. It is called as a NAT translation because it has translated the private IP address to the public IP address, right? So in our case, the private IP address is 172.16.1.1, and he has, let's say we are using a public IP address of, let's use our IP address 14.139. This is the actual IP address which we are using in NITO Chandigarh. 13.19960. dot 225 225. So this is the IP address which is vacant with the router. Router said, okay, you are coming from a private IP address, and what I can do is I can provide you with a public IP address. So he said, okay, you can take this public IP address, and you can go and access to the internet. So PC1 was basically, successful to go to the internet. So at the same time, at the concurrent time, PC number 2 also approaches to the router and says, listen, I'm coming from a private IP address of 172.16.1.2, and I want to also go and to access to the internet. It's a massive situation for a router. So router said, okay, I'm short of, public IP address. How can I allot you an IP address? What router can do is he can either wait for the PC number 1 to, free this particular IP address, because once this IP address is free, then only your router can allot this public IP address to the PC number 2. But PC number 1 is also accessing the internet, and the PC number 2 also wants to go and access to the internet now. So it's a really challenging situation for a router right now, because he's short of the public IP addresses. So NAT is not that a good solution. We do recommend NAT, but in case, let's say you are having more than 2 or 3 public IP addresses, and let's say you have your DMZ, right, demilitarized zone, where you can have your web server, mail server. In that scenario, you can, do the NAT translations, and you can permanently allot, a static IP to your website, to your, let's say, to your mail server, to your DNS server, and whatever thing which you're using in your corporate network. So NAT is not a good solution once you are having once you are short of the public IP addresses. So here I introduce a new term to you, which is called as a PAT. This is called as port address translation. Now, what do I mean by port address translation? Are we people aware that in our TCP suite, we have certain range of, port numbers which is available with us. Let's say from port number 1 to 65535. So we have this particular range of ports available with us in the TCP IP suite. Out of these 65535 ports, up to port number 1 to 1024, I repeat, from port number 1 to 1024, these ports are your well-defined ports. Now, what do I mean by a well-defined port? We do know that, right? HTTP is basically using your port number 18. That's well defined, right? When the RFCs were written, they are predefined. Let's say if we talk particularly about your what we call it as HTTPS, we are already using port number 443. If we talk about SSH, we are using port number 22. For Telnet, we are using port number 23. SMTP, Simple Mail Transfer Protocol, we are using port 25, right? So these all are predefined. So now what actually happen is, whenever you're going and access to the internet, majority of the time, if you want to access to the internet from your PC, that's for sure that you will be using your browser, right? Browser. You will be using this browser, right? So what happens is, there is a TCP three-way handshake mechanism. Let me use, another. Let's not save it. TCP three-way handshake we are talking about. Three-way handshake. Let's say this is your PC. And this is your, let's say, are everyone's favorite, right? www. Let's say f.com, basically your facebook.com. FB. That was in my previous laptop. So this is, let's understand about the TCP three-way handshake. This is, let's say this PC. If you remember the previous scenario which we were discussing, that here we have a switch and here we have a router which is going and connecting to our internet. So this PC says, okay, I'm coming from one of the port number. Whenever you open up a browser, right, what happens behind the scene is the browser generates some random port number which will be always greater than port number 1024. Because till port number 1024, they are already predefined and you cannot use such port number. Let's say this browser came up with the IP address. This was having an IP address of 172.16.1.1, and this came with the random port number of 5000. Port number 5000. And this combination of your IP address and your port number, this is basically called as your socket. This is your socket. So we have a router here in between. If you remember from the previous drawing, and he was having a vacant IP address of 14.139.60 and .225. This was the public IP address, basically, which was vacant with your router, right? So this PC approaches to this router. He says that router, now this time we are not using NAT, but we are using a port address translation. That's why I've already explained to you about the concept of what are the ports, how these are generated. These are randomly generated by your web browsers, so you need not to worry about it, and this process happens basically behind the scenes. So this PC, what it will do is it will go to a router with a random port number of 5000. It'll say, okay, router, now I want to go and connect to the internet. I want to go and surf the facebook.com, and I need a public IP address from you. Router says, okay, now I'm short of public IP address, but what the network administrator has done is he has configured a PAT, which is port address translation, onto me. So what I can do, is I can make use of this port number, and I can allow you to go to and access to the internet. So it will create an entry. This router will create an entry and will say, okay, I'm allotting you a port number I am allotting you IP address 14.139.60.225, the same IP address which it was having earlier, 225, and I am storing this port number of yours, port number 5000. So basically what you can do is now you can go and access to the internet. So this PC came with this private IP address and this port number, went to the router. Router said, okay, I have this IP address vacant with me, and I can allow you and go to the internet using your port number which you have came up to me, right? Which was in our case was port number 5000. So this can go ahead and go and browse to the internet. Another PC, let's say PC number 2 again came. PC 2 said, okay, I also want to go to the internet. So PC router said, okay, I can allow you to go to the internet, but I need to know your random port number which you have generated. PC number 2 said, let's say I have generated a random port number of 6000. Right? So what router will do is it will create another entry in its table that what I'm doing is I'm allotting this 14.139.60.225 with a port number of 6000 to the PC number 2. So this is how basically, there are so many PCs which can go simultaneously go and access to the internet, because we have total of 65535, right? These are the number of ports which are available with us, and we cannot use 1024 ports. So these are the ports which we cannot use, right? But still we have this much ports available with us. Around 64,511 ports are vacant. So this is how basically, many of the users can go and access to the internet with this mechanism pack by only having a single IP address, but they will be using different port numbers. Now, some of you might ask a question, what if, let's say, since they are randomly generating this port number, let's say if two PCs randomly generated a single port number, then what will happen? In that case, to answer this, routers have a tendency to deal a packet after 1 millisecond. So let's say a PC number 1 also came with the port number 5000 and PC number 2 also came with the port number 5000. So whoever will reach to the router first, router will, assign that particular port number to, let's say, PC number 1, and PC number 2 also approach to the, router that I am also coming from a port number, 5000. So router will say to the PC number 2 that no, since port number 5000 is already being used, so I request you to come with a different port numbers. When it will come with a different port number, it will be allowed and go to, and it will be able to go to the internet. So this was a small, introduction about the router, basically what your routers are doing, what TCP three-way handshake is, what is NAT, what is PAT, which is a more preferred mechanism. In case if you are having, many vacant public IP addresses, you can go and use NAT only for your DMZs. That's a recommendation from my side. And in case if you are short of, IP addresses, then PAT is always the, a mechanism which will come really handy in case you have, multiple users and if you are short of public IP addresses. So let's go ahead and, basically use. Basically, today's task basically is to, to brute force the credentials of a router. This was actually to security mechanisms, security issues in your router. So what I'll be doing is I will be using a Linux system. This is my Linux box, if you can see at the remote centers. And I will be using an open source router, which is called as VYOS, VYOS. This comes from a company called as Brocade. But the good thing is, they have kept it as an open source. The community edition is also available with us. So we will be using this VYOS. This is the community edition of this router. So this is, if you want me to, explain to you how you can go ahead and, configure your VYOS, I can do. So let's run this machine. And in case if you don't want to use VYOS, there are other open source, software-based routers available with us. We have OpenWRT. You can also use that. You can see my VYOS is coming to life. So this is my Linux box. I don't know whether this is visible to the remote centers or not, but what I'll basically try to do is I will take the SSH session for the more, so that it will be easy for you to have a look at it. The default credentials for this VIOS is VYOS is the default username, and the default password is VYOS again. So as you can see that I am inside this router right now. Show configuration. The IP address of this machine is not set right now. So what I need to do is, first of all, let's try to allocate an IP address to this VIOS machine from this LAN segment only, so that we will be able to access this machine. So this is my Linux box from where we will be going and brute forcing the credentials of a router. Let me have a look at the IP address of my Linux box first of all. As you can see, the IP address of this machine is 192.168.228.134. So maybe let's say I should also allocate a a kind of a similar IP address from this range only. Let me allocate an IP address to this VIOS machine as 192.168.228.140, let's say, and of course it's using a class CMAS. To configure a router, right now we are into the privilege mode, so we need to, if we need to do any sort of configuration onto a router, we need to enter to the configuration mode. So configure is basically the command. It will, if you can see, if the time I hit enter, this VIOS @VIOS, it will change to a pound symbol. Can you see? Earlier it was in the $sign, now it is in the pound sign. So now, if you have not used routers before, I will really recommend you and suggest you to go and have a look at the basic functionality of a router. In case if you want to have a look at any sort of configuration, what is the previous configuration onto a router, you can use this command called as show configuration. In case if this is not visible to you, just hang in with me till couple of minutes. I will take the SSH session and will explain each and everything to you. Show configuration is the command. This basically shows that this has a interface called as ETH0, and a loopback address is also there. If it is visible to you, you can have a look at here is that it is login user VIOS. This is the same user through which we have already logged into this particular machine. NTP server is also running, and there are the few other things. So now I need to configure this router. I need to enter into the configuration mode. Set interfaces, Ethernet, ETH0, address, and I need now I need to allocate the address. I think the IP address which we thought we planned actually to to give to this machine was 192.168.228.140, followed by a subnet mask in a CIDR notation /24, which I have already allocated to it. IP address is allocated. Now I need to commit the change which I have made. Commit, and then you need to save it. If everything is hunky-dory, now I should be able to ping this Linux box. This Linux box was having the IP address of 192.168.228.134. Let's try to ping it 192.168.228.134. As you can see, the reply is already coming. So what now I need to do is I need to turn on the service of SSH. Set service SSH. Commit again, and you need to save it. That's done. If we have a look at show configuration, now you can see that the IP address is also allocated in the service portion. We can see that SSH is there and things like that. Now let's do one thing. Let's go to this Linux box and let's try to take the SSH session. So what I have already done is I have already written all these commands for you people. If you want, I will hand it over to you while going, or I'll hand it over to Garima ma'am. So you need not to worry about the commands, right? Just listen to me right now. So now what I need to do is I need to take the SSH session, SSH-L followed by the username Vios and the IP address 192.168.228.140. Something went wrong. I don't know what is the issue. Same -L VYOS 192.168.228.140. Remote host identification has changed. It is possible that someone is doing something nasty. Don't worry, router. We are doing some things. Show configuration. Just a second. These things do happen once you are giving the presentation, so don't worry. Commit. I don't know what is wrong with this. RSA host key for this has changed and you have requested strict checking. Never faced this issue before. So basically what I have done is I have already written all these commands for you people. Whatever command which I used so far, this delete interface command is something which I haven't used. Let's say if you want, I'll give this small handout to Garima ma'am and you can collect this at the later stage from her. To allocate an IP address to the router, the command was set interface Ethernet ETH0 followed by the address, and in our case we have used 192.168.228.140 followed by the subnet mask, right? And then you need to commit the changes and you need to save it as well, right? This is basically to delete an IP address from the interface of a router. So this is the command. This particular command which I have used is to turn on the service of SSH. So you need not to worry about the commands at this stage. If I want to, let's say, turn on SNMP set service, SNMP, Simple Network Management Protocol, commit. Let's use version 3. In case if you're having any sort of doubt, you can hit the question mark and it will show you the commands, right? And save it. If we go ahead and have a look at the configuration again, you can see that the IP address is already allocated to this machine as 192.168.22.228.140. There are basically two services which are up and running. One is your SNMP v3 and another one is your SSH. To clear this, you can press Ctrl L, configure. Let's use port 22 only. At port number 22. I don't know why this is giving error today. So let's do one thing. Let's simply go ahead and try to brute force the credentials. But first of all, I want to know what are the services which are running onto my machine, onto this particular router. So what I will be doing is I will be using a small scanner called as Nmap. Basically, it is a king of scanners which we can use. Nmap, it comes with many options. These all are the options available with your Nmap. You are free to explore all these options which are available here. So, but I will be using only few options. I will be using Nmap -small s, capital V stands for verbose. This small s stands for your service. So basically, what are the services which are up and running onto your router? In our case, we already know that one your SSH is running and another is your SNMP which is running. Of what particular IP address which you want to scan? 192.168.228.140. Press enter. So this basically shows us that this particular service SSH is running onto my router which is having this particular IP address. Can you see? 22 TCP, state is open, and SSH. And basically it also shows that what version of SSH you are using. We are using Open SSH here. And it also tells that this is not a real device, but this is a virtual machine. Can you see this VMware written? And this is having a MAC address of this particular. This is the MAC address basically. And in case if you want to have a look at Nmap in much more depth, let me turn on this Windows machine and let me run exam server. Let me have a look at the IP address. This is having an IP address of 192.168.228.133. Let me take a remote desktop session of this machine so that we need not to hop between both the machines. The username of that machine is victim and the password is $$W0RD 192.168.228.133, I believe. Okay, so we are into this machine. Can you see? Now let me go on to this exam server and run various services. So it's already running. Apache is already running onto this machine. MySQL is running with the port number of 3306. FileZilla is running, and let's run the Mercury mail server as well. Now this Mercury mail server is running port number 25, port number 110, basically for POP3, and port number 143, which is used for your IMAP version 2. Now let's perform the same scan using Nmap, and let's see if whether our Nmap is able to figure out that what are the services which are running onto your Windows machine. Give it some time, and I recommend you not to do it onto a live network, production network, because it will degrade the performance definitely. So this is again one of a issue that that any malicious user, what he can basically do is he can run the Nmap scan, and he can actually figure out what are basically the services which are up and running onto your machines, onto your web server, or onto your router as well. Let's give Nmap some time because it will generate a huge amount of traffic, and it takes time to to figure out that what are the services which are running there. In case if you're having any sort of queries, you can ask me. Oops, Nmap has come up with the very drastic results, but it has done its task. As you can see, the port number 25 was basically up and running, which was used by your Mercury mail server, and it is using this particular version of SMTPD. Port number 79 is running onto my Windows machine. Port number 80 is also running, and these all are the various ports which were actually running onto my Windows box. Apache is running, right? Apache is used for your web services and things like that. Port number 80 was also running. So basically Nmap has done its task, that it has shown that these are the services which are up and running. So we should get a good amount of idea, right? That Nmap is basically used to scan what are the services running onto let's say onto your web server, onto your mail server, or onto your routers or things like that. So now our task is to go ahead and first of all we will configure a username. We'll configure a user onto our router, which is our BIOS. We'll configure a user and we'll try to brute force the credentials of the user by using small little utilities. Let me turn on this MSF console. And believe me, I've never faced an issue before. Let me try to log in once again. 192.168.228.140. Something is wrong with this router. I don't know why it is behaving like this. It is acting funny today. So let's go ahead and let's go to your BIOS and let's try to configure a username called as admin2, which will be having a password called as VY $0. The default credential is VIOS. Username is VIOS, VYOS, and the password is VYOS. But for our sake, we will be using the password as VY0 followed by a $sign, right? So I need to configure a user here. I'm sorry, it's my bad. I won't be able to show it to you. I don't know whether it is visible to you, but you need to believe me that I'm typing the same commands. Set system, login, user. Now what user we want to configure? We want to configure a user called as admin2, right? Authentication, let's say plain text password, and we want to have a username of VY0 and a $, right? Let's hit enter. Let's commit the changes and save it them. Show configuration. If I don't know whether it is visible to the remote centers or not, but as you can see, under the login, this is written user as admin2. Some authentication is there and the password is in the encrypted form right now. Okay. So our task is to go ahead and brute force these credentials. We know that the password is the username is admin2 and the password is VY $0. Let's try to take the SSH once again. SSH-L admin2 192.168.228.140. I don't know why this is giving trouble today. And believe me, while coming here, I just tried to I did a practice before coming. It was working like a charm. Same system. But as you can see that I'm getting the reply, so I have the reachability base, right? So what I need to do is I need to go ahead and use a small utility called as crunch. I need to create the list of passwords, which will use and will brute force the credentials, right? And if you want to have a look at the commands, that's already written for you here. You need not to worry. Crunch. This basically says that that you use the minimum length as 4 and the maximum length as 4 as well, right? And use the credentials. Use the alphabets that $0, V, and Y. So it will generate all the possible username, it will generate all the possible combinations. And let's save it in the file called as password.txt. And believe me, if you're using Crunch, you need to be really patient. Sometimes it will generate the list of username in the right format. Sometimes it will act funny, okay? So let's go ahead and use this Crunch. Otherwise, what I have done is I have already created a file while coming here. I created a file called as pass.txt. As you can see, right, here are all the possible username and passwords which are there in this file, pass.txt, starting from VVVV, VVVY, VVV0, VVV$, and all the possible combinations. Basically, around 256 combinations are there. And out of these 256, we have one right username, we have one right password, which is VY0 and $. So first of all, let's try to use Crunch. Let's see whether Crunch is able to create the right set of passwords for us. If you want to have a look at the usage of Crunch, it says the usage is use Crunch with the minimum length, maximum numbers, and what are the options which he needs to use, right? Crunch, minimum 4, maximum 4, $0, V and Y. These are the options. And let's try to save it, this file, onto, let's say, stc.txt, right? It has not generated the right. It's basically blank. I told you, right? Crunch acts funny at times. Again, it has not generated the right files for us. Let's say text.txt. Let me delete these files, stc.txt and text.txt. Don't worry, I already told you, right, that Crunch acts funny at times. We already have this file called as pass.txt, which I have already generated with help of using Crunch only. Crunch, minimum 4, maximum 4, options. And let's try to save it in password 1.txt. Still, it's not working like the way we want. And basically, you can go ahead and see, right, that this particular file is blank right now. So no worries, we already have a file with us called as pass.txt, and believe me, this file has been generated only by using Crunch. It's nearly impossible for me to, go ahead and write all these combinations for you people. So this file has been generated using Crunch only. So now what I will be doing is I will be using a small but a very handy framework called as Metasploit. Metasploit is a kind of a framework which is actually written in the Ruby language, and till date it is the largest ever written program in Ruby. This was actually written in year 2003 by a person known as H.D. Moore. The wonderful work has been done by him. But he wrote this framework in the Perl language. But in the year 2007, this framework was acquired by a company called as Rapid7, and they converted that Perl written framework to the Ruby written framework, and this is the largest ever written framework till now in the Ruby language, right? So basically what I will be doing is I will be using this. To start the Metasploit framework, you need to use the command called as MSF console that we have already used. Just to show you that I used the command called as MSF console, and I was able to enter into the Metasploit framework. So now next task is there are certain modules in this. I won't be able to explain this in the short session. Scanner, SSH. Now, and what I want to do is I want to basically go ahead and brute force the credentials of the SSH, which in our case is admin2 and password is VY0$. Set blank password as false. Set password file. You need to give it a file. In my case, it is pass.txt. You need to set the R host, stands for the remote host. In our case, it is 228.168.140. This is basically the IP address of the router. In this case, this is a private IP address. If you are, if you are onto a real network, that's for sure that router will be having a public IP address. We have already covered this in much depth. What do we mean by public and what do we mean by a private IP address? And what are the ranges available? Set stop on success to yes or to true. If you find the right username or password, we request you to stop. Don't go ahead. set username. Let's set this username as admin2 only, or otherwise what I can do is I can go ahead and I can create another list of user. Let's say nano user.txt. Let's say user as admin. Let's say user as admin2. If it is a Linux system, let's say root or administrator, and things like that. But for our ease, what I will be doing is I will be using a username admin2 only, because we know, because since this is for the demonstration purpose, so let's not make this demo a really long one. And let's set threads to 20. And now let's run this attack. It is starting the brute force. Can you see that this has already tried this username as admin2 and the password is VVVV, but this was the wrong username and the wrong password. Sorry, the right username but the wrong password. So let's give it some time. As you can see that it is using all the possible combinations which are already mentioned in your pass.txt file. Just keep your calm, be patient. Let's have a look what this Metasploit framework can do for you. It has reached $VVV, but we know that the right username is VY0, right? Okay. Can you see this? Our Metasploit was successfully able to go ahead and brute force the credentials of the router. Can you see? 192.168.228.140. On what port number? Port number 22. And it got a success after so many failures. After these many failures, it got the success and said, okay, the right username is admin2 and the password is VY0. Can you see? Remote centers? After so many failures, finally it was able to successfully brute force the credentials of the router. So this is the power of your Metasploit. So now let's go ahead and just to verify, though we already know that this is the right username and password, right? Let's use another small utility called as Hydra. This is basically, Metasploit can basically do tons of things for you, right? But let's use another tool called as Hydra. Let's use Hydra. -L stands for your admin to user. -P, you need to specify your password.txt file. 192.168.228.140. And you need to specify what particular service where you want to brute force this. Let's hit enter. Perfect. Can you see that Hydra was really quick? Hydra cracked your password like in few seconds only. It says that the right username is admin2 and the right password is VY0. So your Hydra was successfully able to go ahead and brute force the credentials. So we have now brute force the credentials of the router using two tools. One is your Metasploit and another is your Hydra. So now let's use another tool called as Medusa. I really like the name Medusa. Let's use this. Now, why I'm showing these different tools to you for the same demonstration, it's just because that you should have all these tools in your arsenal once you are performing any sort of pen testing or things like that. So you should be aware of all these tools, let's use Medusa 192.168.52. No, it's in our case this is 228.140. Tag Q followed by the user admin2, tag capital P, password.txt file again you need to mention, and you need to mention that you need to run this attack for the SSH service. In the similar fashion like we mentioned here in case of our Hydra, as you can see, Hydra -L stands for the username, -P we specify the password file, we specify the IP address where we want to run this Hydra, and on basically onto what service. In our case it is SSH. Now let's go and use Medusa. Hydra was super quick, right? Let's say in how many minutes or in how many seconds Medusa can go ahead and basically crack the username and password for us. Medusa is on the way. You see that there are a total of 256 combinations, and Medusa is trying all these combinations one by one.
If anybody wants to change the settings of routers from far away place,
that is also possible. Once you have the credentials of a router, you can log in, right? Once you have logged into a router, you can do any possible things. So let's give Medusa some time. I think it is about to crack, because we know the password is VY0$. It has already reached to VY0Y. Okay, perfect. Can you see the password is found? Account found. The username is admin2, and the password is VY0$, and it is successful.
Then after that, if he is able to find out the password of this router, then after that, what he will or she will do?
The malicious user might log in into this router, right, and delete all the possible configuration. Then you will not be able to go and access to the internet, right? Or what he can do is basically, he can redirect the traffic not to the internet but to his corporate network, or let's say to his private network, right?
Even the router people, they are not aware.
Yes, even they are not aware, right?
They are not aware that their traffic is routing to something.
Absolutely. And what other thing he can do is he can basically go ahead and change the username and the password of the router.
You are not able to log in.
The legitimate user will not be able to log in, and at that time it will be a really challenging situation for them. So the only possible option which will be left available to them will be to go ahead and to power of the router, so that that cannot be used for the malicious activities.
What are the solutions for this?
The only solution is that you should always keep a really long password. But as you can see that this is the password which we are using right now is not a simple password. It is a complex password, right? Because we are using the alphabets, we are using numbers, we are using special characters. But still, I'll recommend you to to use a password of around a 13-character long password.
Basically for all the activities.
For all the activities, not only for this, but for all the activities. Absolutely. So this was what in my mind was to demonstrate basically how you can go ahead and brute force the credentials of a router. So this is in front of you. This is our Metasploit. This is our Hydra, and this is our Medusa. So now let's go ahead and let's try to strip off the SSL header. Now this is something which which I love to demonstrate, because it is for the awareness purpose, that whenever you are logging onto your let's say Facebook, Gmail, you should always have a look that it should always come up with the HTTPS, not with the HTTP. let me go in here and let's try to open up your Facebook. I think everyone loves Facebook. Facebook.com. Can you see that whenever I try to log into the Facebook, I wrote only Facebook.com, but it came up with the HTTPS, right? Now, why this HTTPS? This HTTP in conjunction with your SSL forms your HTTPS, and HTTPS works on your port number 443. So now, as a malicious user or as an attacker or as a cyber criminal, though I'm not a cyber criminal, but just trying to let's go into their mindset and let's try to strip off this SSL header. What we'll be using is we will force this Windows user to use HTTP instead of using HTTPS. Okay. So for this, what I need to do is, first of all, I need to turn on the IP forwarding capability onto my router. Let me go on to my paint. Then only I will be able to explain it to you what I'm trying to say. File, open new. Let's not save this. Let's understand the scenario, right? Let's say this is our good user. This is our actual user. Let's say this is our Windows machine. And this is our Facebook server. Let's say FB server. This is our FB server. So now what we'll do is, this server has nowadays majority of the servers having the requirement that they only form the connection using HTTPS. They're not using your HTTP. So they have a special requirement that any sort of connection which these servers will form, that has to be your HTTPS. So now our malicious user approaches, he will act as a man in the middle. Let's say, a bad user. Let's try to configure him. Let's say a bad user, the bad teeth and things like that. He's the malicious user we have. Now this malicious user will perform the man in the middle attack. MITM. Right? So what will happen is, the traffic which he wants to send to this Facebook.com will first of all go to this malicious user, and on his behalf, this malicious user will form a connection with Facebook.com. Since Facebook.com is having the requirement that any connection which they will form will have to be HTTPS. But our malicious user, what will he do is, as he is forming the connection on his behalf, on the behalf of this PC, of this Windows PC, he will form the connection in the HTTPS only. But here he will send the traffic in using HTTP in the clear text. At that time, he will be able to clearly see what are the username and password which this PC1 is using. Right? I hope the scenario is clear to you. Let's go and let's try to demonstrate this. First of all, I need to turn on this IP forwarding capability, because if you can see, right, now the traffic will be going from my machine to the internet, right? So my machine is not having the IP forwarding capability, right? So let's try to turn on this IP forwarding capability onto this malicious machine or onto this malicious user. Let's run this. Let's copy this and let's paste this. Basically, you have turned on the IP forwarding capability. Now I need to write certain IP table rules. Let me explain this rule to you just in a second. It basically says that if you receive any sort of traffic for port number 80, you should redirect it to port number 8080. Can you see? Redirect it to port number 8080. Okay. Let me try to figure out the gateway first of all. The gateway is 192.168.22.228.2. Now let me turn on the R spoofing. R spoof -I ETH0 TAC T. The target IP address is 192.168.228.140, followed by the IP address of the gateway, because we are spoofing the IP address of the gateway. Now our machine, our malicious user machine, will act as the gateway, right? 192.168.228.2. As you can see, my IP spoofing is on. Now the traffic will not go to this gateway, but it will come to my machine. And we have already turned on the IP forwarding capability, right? Let's open up another terminal and let's run this SSL strip. Copy. Just a second. ls here. Let's paste this here. Paste it. And we are good to go. Let's go and try to run this Facebook again. As you can see, earlier it was HTTPS. Now we have orchestrated our attack. Let's try to run facebook.com once again. And if this time everything is working perfectly, we should see the Facebook connection using HTTP, not with HTTPS. Something went wrong this time with us. I don't know why. Just a second. It came up with the HTTPS, though it's a good thing. Let me, first of all, stop these services. They might be, okay, sorry. I need to tell you something that by mistake, I have entered a wrong IP address here, because this particular IP address was of our router, not of our Windows machine. So let's first of all try to find out the IP address of our Windows machine. I hope this was 192.168.228.133. Yes, it's 133 only visible, right? Can you see? Let's try to run this once again using 133. Let's run this. And this time, let's go to this machine. Let's try to run this Facebook once again. .facebook.com. Just a second. Let's try to enter some random password. Let's say saurabh@gmail.com, and the password as, let's say, I am secure. I know it's the wrong password, but I'm not sure if this will work this time or not. Let's give it a try. And can you see this SSL strip.log? Let's try to analyze these logs now. Basically, this is blank right now. Let's stop this. Let's try to rerun this. It's here. IP tables -- flush. Let's remove all the IP tables which were previously configured, and let's try to run this in a new manner. Copy. Let's do it 0 because we changed it to 1, and now again change it to 1. Change it to 1. Copy this. Again, create the rule. argspoof-I equals 0 tacti 192.168.228.133, I believe. Well, these things do happen at the time of presentation. .228.2. Our spoofing is up and running. Let's try to rerun this SSL strip. Our SSL strip is giving trouble actually. Basically, I've killed the process. Just a second. Let's try to run it on port number 8000. Let's give it another try. Let's hope this time it works properly. I don't know why this is acting funny today. It is all again coming up with the HTTPS, but in my previous session, my videos are available onto YouTube. You can have a look at it with the same procedure. It will come as HTTP, not with the HTTPS. Just a second.
Write your video links.
Just a second. I believe that Gmail is coming up with the HTTP.
say Madhu already logged in again, और already logged in. उसमें भी problem है.
उसमें issues I think. It's not coming. I'm sorry. I don't know why. But basically, what you can do is, if you are going in here and let's try to run your www.gmail.com. gmail.com. Close all tabs. Let's run a single Gmail. www.gmail.com. Net is really slow. Let's stop this. Stop this as well. Sign in. Let's say as a normal user, I'm signing in here as a Saurabh @NITTTR csg.ac.in, and I'm using a password which is not the right username and the password, right? What I would have done is I would have logged in with the right username password as well, right? So for a normal user, the password is gone now, right? But this password is somewhat still available in your RAM. Applications. Create a dump file. Let's copy this. Okay. Close this. Close this. iExplorer.dump. This is the file basically which we are interested in. We have just created a dump of this file. Let's cut it and let's paste it here onto the desktop, and let's try to analyze this file and let's see if we could figure out the password. Let's use HXD, a small utility. Let's open the file. In our case, the file is iExplorer.exe. A really difficult task to analyze this file, right? And we need to figure out a small password. The password which I used was I am secure. Let's press Ctrl F. Windows stores each and everything in the Unicode. Let's say password not found. Don't come to any sort of conclusion so easily, right? Always keep your calm. Aha, can you see that the username which I used was Saurabh @NITTTSCSG.ac.in, and the password which I used was I am secure. So you were basically successfully able to go and dump the password from the RAM. So this is the live RAM analysis, though this was not planned in this session, but since I was not able to perform SSL strips, so I thought maybe why not give it a try and show you how you can go ahead and dump the RAM and you can do the live analysis of the RAM. So if it is visible to all the remote centers, can you see that this is the email ID which I used, saurabh@nittscsg.ac.in, and the password, definitely this is not my right password, I am secure. But let's say if for a normal user, he might have logged in with the right username and the password, right? So this particular password was still available in the RAM, and we were successfully able to go and grab the password using live RAM analysis. So with this, I come to the end of the session. In case if you are having any sort of queries, you can please ask me. And I'm really sorry, I don't know why my SSL strip acted funny today. Any queries from any remote centers, you can please ask me.
Any query from any of the center?
Yes, from 5 Madras Indian Engineering College. Yes, sir. At 5, do you have any feedback or question for this session? Or at Maharashtra College of Engineering?
ढूंढना पड़ेगा वो पुराने वाले में सब कुछ
Just to
Thank you all the remote centers. We'll see you in some other STC now. Thank you, ma'am, for giving the opportunity.
All right, then we'll reassemble tomorrow at 9:30. Now we can call it a day. Thank you.
इलेक्ट्रॉनिक्स वालों के लिए कंप्यूटर्स कमांड्स ना थोड़ी सी वो होती है
टफ रहती हैं
टफ रहती है
बट ये सही था ये रैम वाला सही था ना ये
उनको मुश्किल लगती है थोड़ी वो यूज टू नहीं होते ना उस चीजों के
मतलब खुद इलेक्ट्रॉनिक